Alright guys, welcome everyone. So hope you all are doing good. Now in this section we are going to cover everything from week 1 all the way to week 8. And I know that sounds like a lot, but don't worry, we'll cover everything. I guess you may have already studied the week 1 to 4 and you may have some knowledge on it. So what I'm going to do is I'm going to cover the main ideas from those weeks. I mean just the important bits, and then for each tricky topic we'll solve some questions. Because knowing the concept is one thing, but understanding how the exam answers it is a different thing. And right, yeah, that's what we're gonna do now. And for week 5 to 8, those are the newer topics. We'll go a bit deeper there. All right. Okay, as you can see, these are the topics we're going to cover in this section. So the first one is here, the variables and iterators. All right. So let's start with the variable. Here, a name used to store a value. Yes, that's it. A variable is basically just a name that holds a value. That's it. Think of it like a label box. You write a name on the box and you put something inside it. So if I say x equals to 10, that means the box called x is holding the number. Simple. Now, in the slides, we saw examples like count equals to 0 and the sum equals to 95. So it means the count is a box holding 0 and sum is a box holding 95. You can change what's inside the box later also. Yeah. And that's the whole point of a variable. Now, iterators. Okay, so an iterator is just a way to go through the every element in a collection exactly once. It means a mechanism to access every element in a collection exactly once in a specific fixed order. That's it. So imagine you have a pile of cards, the pile 1 and the pile 2. These are the cards you haven't looked at yet, and you pick one card, do something with it, and then you move it to the pile 2. Here the pile 2 is the done pile. You keep doing this until the pile 1 is empty. That's literally what an iterator does. It goes through the every card one by one and makes sure that you don't miss any and also you don't repeat any. That's it. Very simple. Now, okay, moving on to the flowchart here. So a flowchart is just a visual way to show an algorithms, like a series of steps. It uses the specific shapes, and each shapes means different things. Like let me go through them quickly. Here the first one is oval. That's the start or stop of your program. Like whenever you see a rounded shape, you know the algorithm is beginning or the ending. That's it. And the rectangle here. Here this is a process like doing a calculation or assigning a value to a variable. So here the count equals to count plus 1 would go in a rectangle. And now next one is a diamond. That's a decision here. Yes or no question, like is x greater than 5? If yes, this go this way, and if no, go that way. That's it, simple. And the last one is the arrows. Here they just show the direction, like which steps comes next and what in what way. Okay, that's it. So yeah, in this flowchart we actually pulls together everything like we just discussed right now, a variable and the iterator and the flowcharts, all these things. Yeah. So here the first one is a oval. We start here at the top, and ovals also shows us the start and the end of our process. And here you can see the arrow. This shows the direction. Just follow them to see exactly where the data is moving to the next. And the next one is a green rectangle here. These are our variables. We start by initializing the count to 0, and at the bottom we are updating it by 1, like we are incrementing the count. And here the purple diamond, this is the decision. It asks the questions, are there more cards, like more cards in the pile 1? And then if yes, go this way, and if no, then end it. And the next one is a blue rectangle here. This is the iterator in action, like is the physical work of picking a card and moving it so we don't get stuck. Next, the iterator loop. Here this one is the iterator loop. See that the long dashed line and the arrow on the left, that's the loop. It forced us to repeat the steps until the diamond finally says no more cards left and sends us to the end oval. That's it. Very simple. Now let's go to the sanity of data. Now here a sanity check is basically a reality check on your data. Like before you do any complex analysis, you just ask, like does this data even make sense or not. And here the marks of -20, that's impossible, right? Marks should be between the 0 and 100 unless they have clearly mentioned the negative marking. And also the temperature, 5000 degrees Celsius, that's clearly a sensor error. Yeah. And the final thing is the final phrase to remember is garbage in, garbage out. It means if you feed the bad data into your model, you get the bad results. That's why we always validate our data first. Now the next type, data types. All right. So this is about what kind of value is a variable holding, because different types allows different operations. So let's go through the types. Here the character, a single symbol like M or F for gender, and you can only compare the characters. You can't do math on them, like you can't do addition or subtraction, kind of. And the next one is the integer. Here this is the whole numbers like marks, counts, rank, anything. You can do all the usual math like addition, subtraction, multiplication, division, anything like arithmetic. And the next one is a float. Here the decimal numbers like 3.14, 0.007, yeah. And the operations allowed here is same. Like again you can do the arithmetic and comparisons work. And the next type is boolean. Here the only true or false. And you can use and or not with the booleans. And the final thing is a string. Here the a sequence of characters like a name or a city. Like you can compare the strings, but you cannot do arithmetic on them. For example, marks plus marks is fine, but name plus name, that's an error, right? It doesn't make any sense because the name is a string and you can't add strings arithmetically. That's why. And now let's move to the next one, the pseudocode. Here the pseudocode. So pseudocode is basically writing your algorithm in plain English, but with a bit of structure. Actually, pseudocode can be understood by anyone. Like it's just a plain English, so it's easy to understand. And by the way, you are not writing real Python or the Java or anything. You are just describing the logic in a way that's easy to understand. And this is a card counting algorithm in pseudocode. Here you can see the start and the count equals to 0. While pile 1 has a more cards, pick a card x from the pile 1 and then move x to the pile 2 and increment count and then end. So at the end, the count tells us how many cards were in the pile 1. That's it. Simple. This is what pseudocode means. So now let's look at a example, pseudocode example, and this one is finding the sum of maths marks for boys only. Yeah, here you can see that boys only. So sum equals to 0 while the pile 1 has more cards. Pick a card x from the pile 1, move x to the pile 2. If x gender equals to male, sum equals to sum plus x dot maths. So what's happening here means we go through every card and for each card we check, is this person male? And if yes, we add their maths marks to the sum, and if no, we just skip them and move on at the end. At the end, sum holds the total maths marks for all the boys. That's it. Simple. Alright, so yeah. Here this is a MCQ question from the scores dataset. At the end of the execution, C will be true if there are more female students from Chennai than male students from Bangalore. Choose the correct option to complete the pseudocode. Okay. So here the A equals to 0, B equals to 0 and the C equals to false. While pile 1 has more cards, read a card X if x dot gender equals to female and the city equals to Chennai, then statement 1. Next, move x to the pile 2 and here the pile 2 has a more cards, read card X if city town is equals to Bangalore and the gender equals to male, then increment B. And then B equals to B plus 1, then move card X to the pile 1, then if statement 2, then C will become true. So, okay, what are the statements 1 and 2? Yeah. Okay, let's think about what A and B represent. In the first loop, we are going through all cards and when we find a female student from Chennai, we hit statement 1. So it means statement 1 should contain those students. That means A equals to A plus 1. So here A equals to number of female students from Chennai and here the number of male students from Bangalore. And now the condition for C to be true is there are more female students from Chennai than male students from Bangalore. So more Chennai female students than Bangalore means A is greater than B. So the statement 2 is A greater than B. A greater than B, and the correct answer is A equals to A plus 1 for the statement 1, and for the statement 2 A should be greater than B. That's it. Alright, so the next one is a maximum and minimum. Here the idea is simple, like you want to find the highest or the lowest value in your dataset. The step 1 is to initialize your variable. For max, you should start it very low, like 0 or negative, and for minimum you should start it very high, like 101 if marks go from 0 to 100. It's because you want the very first card to always update the variable. Yeah, that's right. And now the step 2. The step 2 is loop through the every card. For each card, ask is this value better than what I have so far? If yes, then update. At the end, your variable holds the answer. Like, let me show you the code from the slides. Max m equals to 0. While pile 1 has more cards, pick a card x from the pile 1, move x to the pile 2. If x dot max is greater than max m, then max m equals to x dot max. So here, we are just keeping track of the biggest maths score we have seen so far. Like every time we find a bigger one, we update the maximum. At the end, maximum is the highest maths marks in the whole dataset. That's it. Okay, now the next one is a AND operator. Here, it means the AND operator means the both conditions must be true. If even one is false, the whole thing will become false. For suppose if I say the gender equals to m and the total is greater than 200, this only passes if the person is male and also their total is above 200. If the person is female, and even if the person is female, then if the total is greater than 200, like 300, it still fails because one condition is already false, like the male condition. So for AND operator, the both conditions must be true. Now the OR operator. Here the OR operator, it means at least one condition must be true. It only fails if all the conditions are false. For suppose if I say gender equals to F or the total is greater than 250, this passes for all females and also for any high scoring males. That's it. Simple. One condition true is enough. Now the next one, multiple iterations, non-nested. Okay. So multiple iterations means this is when you need to go through the data more than once, but separately. Like here, think of it like you're reading book 3 times, once to understand for the plot and once to study the characters and once to analyze the themes. Sorry. And each time you read it fresh from the beginning to end. So instead of doing everything in one complicated loop, you do simple separate passes like pass 1 for one task and reset, then pass 2 for another task. Now the important thing is that after pass 1, the pile 1 is empty. So it means all cards are in the pile 2. So before pass 2, you need to move all cards back from pile to the pile 1. It means you have to reset the cards. Otherwise your second loop has nothing to work with. That's it. Yeah. Now let us solve one question. Yeah, here we go. So here the following pseudocode is executing using the words dataset. What will A represent at the end of the execution? So the question is asking what A will represent at the end of this pseudocode. Okay, now let's understand the sorry. Now let's understand what the code is doing step by step. First we initialize 3 variables, sum t, count t and the b as 0. Then we start a loop that goes through all rows in the table 1, and for each word we increase count by 1 and add its letter count to sum t. Then at the same time we move each word to the table 2, and so basically it means after this loop count t becomes the total number of words and sum t becomes the total number of letters. So this means the b is the average number of letters per word. Now we set a equals to 0 and starts another loop over table 2, and for each word we check if the word ends with a comma and its letter count is greater than b. Then if both conditions are true, then we increment the a. So it means in the end, a counts how many words end with a comma and also how many have more letters than the average. So it means the answer is this: the number of words that end with a comma and have a letter count greater than the average letter count of dataset. Okay, now next one. Alright, so here the procedures. So a procedure is just a reasonable block of code. You define it once and then you give it a name and then you can call it as many times as you want. It is useful because, for suppose if you need to do the same thing multiple times, you don't write the same code again and again. You can use this called the procedure. The key things about the procedures is they take parameters. Here you can see this gen is called the parameter. It means the inputs that you pass in, they can return a value, a result that comes back to the caller, and they might have some side effects also. Things they change along the way. Here's the example from the slide. So the procedure sum maths of Chen. Here the sum equals to 0. While file 1 has a more cards, sum equals to sum plus maths marks x dot maths, and then return the sum and sum maths. Here you call it like a boy total and equals to sum maths of m. Here gen is a parameter, like it can be male or else a female. That's it. Now let's solve one question from this procedure topic. Here, what is the question asking? What will a represent at the end of the execution? Okay. So here a equals to 0 while pile 1 has more cards. Read top card x from the pile 1. And the card x a equals to a plus is in sequence of x. Then move x to the pile 2. And the procedure here is in sequence of x for if x dot mathematics is greater than physics and physics is less than chemistry. It returns 1, else it returns 0. So here is in sequence returns 1 only when the two conditions are both true at the same time. That are the first one is the condition is mathematics greater than physics, and the second one is physics should be the less than chemistry. So it means if maths is greater than physics, that means physics is not the highest, math is bigger. And if physics is less than chemistry, that means physics is also less than chemistry. So physics is less than both maths and chemistry. So that means physics is the lowest of the three subjects. So is in sequence returns 1 for students where physics is the lowest subject and A is summing up all those ones. So A counts the number of students where the physics is the lowest marks. Yes, and the correct answer is the number of students with the lowest marks only in physics out of the three subject marks. Okay, now the next one is a loop inside a loop. It means the nested iterations. Okay, so the outer loop picks one item and then let's call it a student A. Then the inner loop goes through the all remaining students B, C, D, E and so on and compares each one with A. Then the outer loop moves to the next student and the inner loop runs again. This is a pattern for comparing every item with every other item. For I from 0 to n minus 1, here you can see that from I from 0 to n minus 1, and then for j from I plus 1 to n minus 1. If students I dot month is equals to students j dot month, add the pair. Notice that the j starts at I plus 1. It's because we don't want to compare a student with themselves. That's why it's a I plus 1. And also we don't want to check the same pair twice. And the downside of nested loops is the number of comparisons is roughly n squared to n. So it means n squared. For 100 students, that's literally 10,000 comparisons. And for 1,000 students, you can imagine that's like a 1 million. So it gets expensive and fast, and that's a drawback. And now, one question from this. From the nested iteration. Okay, the question here asking is same. What will A represent at the end of the execution? Here A equals to 0 while table 1 has a more rows. Read row xi equals to the I equals to 1 and the B equals to false, while I is less than or equals to letter count, x dot letter count, if ith letter of the word x word is followed by a vowel, it means the B equals to true, and then I equals to I plus 1. If B equals to A plus 1, if B A equals to A plus 1, then move x to the pile 2, table 2. So here the outer loop goes through the each word x. For each word we said B equals to false at the start. Here the B equals to false at the start, and the inner loop goes through the each letter of the word, and if any letter is followed by a vowel, we said B equals to true. The main point is, once B becomes true, it stays true. It stays true. Like we never set it back to the false inside the inner loop. So it means that even if only one letter is followed by a vowel, the B becomes true and it stays true. So it means after the inner loop, we check is B true. If yes, then increment count A equals to A plus 1. So we count this word. So A counts every word where at least one letter is followed by a vowel. Not exactly one or not all of them, at least one. So here the correct answer is the number of words with at least one letter followed by a vowel. Okay. So far we have completed week 1 to 4 all the topics, and now we are moving into the week 5 to 8. So from week 5, the first topic is collections. Here the first one is a set or dictionary. For set and dictionary, we use curly brackets. Here these are unordered and they don't keep things in any particular order, and also you can't repeat the elements inside the set. And the second one is list. Here it uses the square brackets and it's ordered. It means keeping the things in the specific order the way you put them, and it is also immutable. It means you can change it after creating it, and it also allows the duplicates. And the third one here, the tuple, it uses the round brackets and it is also ordered, but it is immutable. It means once you create it, you can't change it or think of it as a frozen list. Yes. And so to summarize this, here the set or dictionary means unordered, unique keys, and also no duplicates are allowed. For list, it is ordered, mutable, and it allows duplicates. And for tuple, it is ordered, immutable, and it is also allows duplicates. That's it. Let's move on to the next one. Here the list operations. So let's go through each operation carefully. Here we have 5 operations: first of L, last of L, init of L, rest of L, and the member L, X. Here the first of L means it returns only the first element of the list. Here as you can see, the L equals to list of A, B, C, D. Here the first of L gives you A, and same with the last of L, it gives the very last element. L of last of L, which gives that D. And for init of L, it returns everything except the last element. So here the output is A, B, C. It drops the last one. And for the rest of L, it returns everything except the first element. So here the rest of L is equals to B, C, D. That's it. It drops the first one. And the member L, X, here it checks if X is present in the list. If it is present, then it will give the true. Here L of X, the member of L, X is equals to, for suppose X equals to C, it means the member of L, C, it will give us true. It's because L is present in this list. For suppose if I say member of L, E, then it will give false because there is no in this list. There is no E in the list. That's why this is how the member of L, X helps. And so, but the most common confusion is the init versus rest. Like actually we mix these up all the time. For suppose, so the simple way to remember is, think of it this way: like init is like initials, It's everything from the beginning up to, but not including the last thing. And the rest is everything that remains after you remove the first. Yes, simple. Now, okay, here are some questions from the based on the above topic. What will be the value of mlist at the end of the execution of the given pseudocode? Here, the list contains 0 to 10, 1 198, 2 188, 3 173, 4 240. It means the list in lists. There are so many lists inside the list. And for here the mlist is equals to empty list, and for each element in L, mlist equals to mlist plus append last of element. Here it means we only take the last element. Okay, so let's go through this step by step. And for each element in L itself, a list with the two elements, two items. So here the element 1 is 0, 210, as you can see the whole. And then now last of element means, if I say the last of 0, 210, then it will give us the 210, because 210 is the second one which is last. And for this last of 1, 198, we will get 198, and for this 188, and for this 173 and 240. So mlist becomes this: 210, 198, 188, 173 and 240. So the correct answer is D. Now let us solve one more question. Okay, so it is also same thing, same idea, but now it's mlist equals to mlist append last of init of element. Okay, and this time each element has three elements, three items. Here the L equals to 0, 2, 10, 78, and 1, 198, 91, 2, 188, 77, 3, 173, 78, and 4, 240, 89. Okay, so now we have a chained operation, last of init of element. Okay, so it always work from the inside out. Take take the first element here, 0, 2, 10 and the 78. Then step 1 is to initial value, init of 0, 2, 10, 78. It means we have to remove the last element, so 78 will be dropped here. And then the step 2 is last of 0 to 10. It means 0 to 10. We'll get the value 210, because for 0 and 210, the 210 is the last thing, because 78 is already dropped at the init of element. So we'll get the middle value. So if you understand this clearly, we are getting the middle values. So for this one is 210, and for this 198, 188, 173 and the 240. So this is how we will solve. So the same answer as the before, but the different path. So yeah, the correct answer is D again: 210, 198, 188, 173 and the 240. That's it. Now one more question. Here we have a non-empty list called author list, and that stores the name of all authors in the library table, sorted in the alphabetical order of other names. And there are the elements corresponding to each book in the table, and this results in many duplicates. So the following procedure attempts to extract the unique list of authors while preserving the sorted order. So the pseudocode may have mistakes. Identify all such mistakes, if any, and it is a multiple select question. Okay, so here we have a list of author names called auth list, and that is sorted alphabetically, but it has many duplicates. It means the same name appears multiple times. So we are trying to create a new list called the unique list that contains each author's name only once. So the pseudocode is here, and we need to find the mistakes. Okay, at line 1 and line 2, the setup first is we create an empty list, unique list, and then a variable called prev set to none. Here the prev means previous values. Then in line 2, here the unique list, we try to add the very first author from our main list into our unique list. And here the error is, look closely at line 2, the unique list is a list. Yeah, so but the first of auth list, it is just a single name. It means a string value. you can't use append to add a single name directly to a list like that. It should be inside the brackets. Here you can see that it should be in the square brackets, first of auth list in the square brackets. So the line 2 is an error here. And the next is line 3, the previous marker in line 3. Here we set prev to the first author's name. This is correct because we need a starting point to compare the next names against. Okay. Now at the line 4, the iterator, now we start our loop and we are looking at the rest of the list, rest of the author list, and then rest of the author list, and everything after the first name, and for every name X in that list we do a check. And in line 5, the logic check here is X equals to prev. And here the error is, think about it, if the current name X is equals to the previous name, it means it's a duplicate, right? If the name is already presented, then it is repeating, right? So it is an error here because we only want to add the name if it is not equal to the previous one. So it should be the not equals to symbol. That's why we got an error here. And now the line 6 and line 8, here the updating the list and the marker in the line 6, we add the name to the list, and this time they used the correctly as X in the square brackets. And in line 8, we update the previous to be the current name X, so that in the next round of the loop, so we are comparing the against the newest name. This part of the logic is actually fine. So to fix this, we need to change the line 2 to handle the list formatting correctly, and change the line and change the double equals to symbol here to the not equals to symbol, the exclamatory and the equals to symbol. That way we only grab a name when it's a new. That's it. Now one more question, and after that we'll move to the next topic. So in this course table we have a list called S. The list of sequence numbers of rows which have the marks greater than 75 in at least one subject. What does the variable count represent at the end of the execution of the pseudocode given below? Okay. So here this list contains the sequence number of students who scored more than 75 in at least one subject in either math, physics or chemistry. So we need to figure out what the variable count is actually measuring by the time the code finishes. Here the first is, we start with the count equals to 0. This is our variable that will store the final answer. And in line 2, here we are going through the table 1 row by row. That's our the first iterator. And for every student X, we then look at the list S. That's our second iterator. We are essentially asking, is a student in our special list S? Special list S means if X sequence is equals to C, this line checks if the student is in list S. Remember, list S only contains the who got above 75 in at least one subject. If they aren't in the list S, the code ignores them and moves on to the next one. But the second filter, if S, will move to the second filter, and in this filter, if they are in the list S, they hit a second gate. And if the mathematics, if the maths marks is less than 75 and also the physics is less than 75, this checks if they are scored less than 75 in both the maths and physics. So it means if the student is in the list S, they must have scored the above 75 in at least one subject. But line 6 just told us they failed to get 75 in math and physics. It means if they didn't get in math and they didn't get in physics, but they are in list S, it means they got above 75 in something. So here the only subject left is chemistry. So it means the final answer is number of students who have scored the less than 75 in both maths and physics, but more than 75 in chemistry. That's it. Okay, now next topic. Here, what exactly is a dictionary? Imagine you have a key to a locker. The key itself isn't the price. It's what is inside the locker that matters. It's what is inside the locker matters. So in programming, a dictionary works exactly like that. It's a collection of key value pairs. You use a key like a label to find a value. It means the data. Value here means data. And first of all, look at this example. Look at the code. My dict equals to name John, and the age equals to 25, and the city equals to New York City. Here name is a key, which is John, and is a value. Here John is a value. Instead of remembering that John is item number 0 in a list, you just ask the dictionary for the name, like my dict of name, and it handles you John. It's much more simple. And there are the three things that you have to remember about is the dictionary is unordered and mutable. It means the computer doesn't care what line they are on. It finds them by the label, not the position. And the mutable means just means we can change the data inside. Like if you want to update the age of the John, you can simply update it to the 26 or anything. That's it. Simple. Whenever we want. And the keys must be unique. You can't have the two locals with the same key. If you have the two name keys, the computer will get confused, and that's why every key must be one of a kind. It should be the unique. Next one is the values can be any type. Yeah. While keys are usually strings, the values can be anything like numbers or lists or even the other dictionaries. Yes. The next topic here this one is the dictionary methods. Okay. Here the some useful dictionary methods from the slides you may get in the exam. Like this one dict.keys. Here it returns all the keys, and here the values. It returns all the values, and here the items. It returns all key value pairs, and here it returns the keys, a safe way to the access. And here this dict.update, you can the update, merge it, and the final one is dict.clear. It means it removes everything from the dictionary. That's it. Okay, next move to the next topic. Here the next dictionary. Okay, we already learned what a dictionary is, but what happens when a dictionary becomes a value itself? That's called a nested dictionary. Here a nested dictionary is basically a dictionary of dictionaries. It means that instead of a key, it just pointing to a simple piece of data like a number or a name, it points to an entire separate list of key value pairs. Here in this first example, look at the first code snippet. D equals to BB, and in that and the dictionary mug is 2 and the t-shirt is 3. Think of BB as the name of a store, and inside that store we have a mini inventory which have mug and the t-shirt. To get the number of mugs, you first have to enter into the BB store, and then you have to check this. Here, that's it. If you want, you can update it also. And then next one is a student example. We have the one big dictionary called the student, and in this the main keys are the names, which are the John and Mary. Here, but John isn't just a single value, he is an object with his own properties. His age is 20 and the grades he got is A, and the same goes for Mary. This allows us to organize a complex data in a way that makes sense. So if I want to find the John's grade, I go to a student and then look for the John and then look for a grade. That's it. Simple. Now let's move to the next topic, updating and the assigning values. How do we update a value that is hidden inside the another dictionary? This is called the updating and assigning values in a nested dictionary. Okay, think of this like a delivery service. Imagine a big box labeled D. Inside that box is a smaller box labeled BB, and inside that box we have actual items, mug and the t-shirt. This is what we call a nested dictionary. A dictionary inside a dictionary. And the before state, look at the before section. Here right now the dictionary says we have the 2 mugs, but let's say that we have just got a new shipment and we need to change that number to the 5. The command, the address to, it means the address. To change it, we have to give the computer the exact address of the value. Look at this, D of baby and then mug, then we'll get the value, which is we'll update the value equals to 5. Then the first bracket BB tells the computer, go into the big dictionary and find the BB folder and in the second bracket mug tells it, now look inside the BB and find the mug tally. Here the equals to 5 tells it, and throw away the old number and put a 5 there instead. Yes, so whenever you see a double brackets like the dictionary of key or nested key of nested key, just think of it as a path, and you are just opening the one door after the other until you find the value you want to change. Here the after thing, the mug is updated to the 5. That's it, simple. Next, how do we check if a key exists or not? Imagine you are looking for a specific book in a library, but if you just grab a random shelf and shout, where is it? You might get an error because the book isn't there. In coding also, we use a special function to knock on the door. First to see if the key exists or not before we try to open it. Look at the first line D here, which is equals to AA, gives the 100, and the BB and the dictionary called the XX1 and the YY2. And we have two main keys here, the AA and BB. Now look at the statement. If is key D, which means here the D is dictionary and BB is which is the element presented in this dictionary. It's kind of like member of dictionary comma X, like that. And this line is like a detective, and it goes to the dictionary D and asks, do you have a key named BB? Since BB is right there here in our data, so the answer is true. So it will print key exists. Because the answer is true, the code follows the first path and print the key exists. But for suppose if we had asked for a key that isn't there, like CC, the code would jump down to the else section and print the key not found. That's it. It is for the first step. Like if you try to update or read a key that doesn't exist, your whole program might crash. That's why by using is key, dictionary comma key, you ensure your code and stays running smoothly no matter what the data is inside this. Okay, now let us solve one question. That's it for this. I guess the topics are done. Now we have only left the questions. Here the first question is, let Z be a row in the words table such that Z word equals to reluctant. What will be the value of alpha dict of t at the end of the execution of the following pseudocode? Here we have a dictionary called alpha dictionary with some initial counts for letters, and we also have a word reluctant, and the code is going to update our dictionary based on this word. Here our goal is to find the final value of the letter T. What is the value of T? Okay, so first let's look at our variable initialization. Before the code runs, the alpha dictionary already has T, has a value for T, and which is 2. Here you can see that T is equals to 2. Keeps that number in mind. We aren't starting from 0. And next one is the procedure. Here the procedure update the dictionaries uses a while loop to go through the every single letter of the word reluctant one by one. And this is our iterator in action. For every letter it finds, it checks our dictionary. The logic if else. First, inside the loop, there is a check if the letter is brand new. If the letter is brand new, then it adds to the dictionary with a count of 1. If the letter already exists, it just adds to the current count. And then the counting the T's in the reluctant. Since we only care about the letter T, we can leave these things like C, S. We don't want those letters. We care about that letter T only. Let's count how many T's it appears, how many times it appears in our word. T appears. Here on reluctant, RELUCT. Here the one T here, and ANT. That's the second one. There are 2 T's in the reluctant. So it means by putting it all together, we started with 2 T's already in the dictionary here, and the loop found 2 more T's while going through the word. It means by adding those 2, the previous one which we already have, and the 2 T's from the reluctant, we will get the 4. So the answer for this question is 4. Alright, now next question. Okay, in this question they are asking what will be the value of B at the end of the execution of the following pseudocode. Okay, let's look at the do something instructions here. It basically sets up a filter it creates an empty dictionary, B dictionary, and then the empty list, which is for our final result. And the loop here, it goes through the every element, every number in A one by one, and the check is for each number. It asks, is this number already in my dictionary or not? If it is not in a dictionary, then it adds the number to the dictionary and marks it as seen and adds it to the result list. Here in the B list, it will add. If it is in the dictionary, it does nothing and moves to the next number. It means the procedure is a unique filter. It only keeps the very first time a number appears. Okay, now let's put this A into this code and then see what we get. Here the 3, 4, 5. These are the first three numbers. None of them have been seen before, so they all go into the list. So the current B list contains 3, 4, 5. Okay, yeah. Now here 3. The loop hits another 3, but the dictionary says I have already seen 3, so it skips it. So this 3 won't count. It won't add into the B list. Now 1, 9. These are new, so they get added. So for now the current list B list is 3, 4, 5 and 1, 9. 3, 4, 5 and 1, 9. Now again this 4, which is already seen, so we will skip. And now 6. 6 is new, so it gets added. So for now we have the 3, 4, 1, 5, 9, 6. And the 5, 9, which is both of these have been seen before, so we will skip both. So the final answer is we are left with the list B equals to 3, 4, 5, 1, 9, 6. That's it. Now the next question. Okay, we have here the question asking what will D represent at the end of the execution. Okay, we have a data set called words, and we are running a piece of code that uses a procedure to change the dictionary D. And by the time this code finishes, what information will dictionary D actually hold? That's what they are asking. So let's look at how the data flows from the table into the dictionary. Here the line from 1 to 6, we have the one loop, and in this loop we start with an empty dictionary D equals to, and we look at the table 1 row by row, and each row X is a single word from our data set, and for every word we call the update dictionary procedure and then move the word to the table 2, so we don't count it twice. Okay, now let us see what's this procedure doing. Now okay, looks inside the update dictionary. This procedure takes a word Y and starts a second loop. It looks at every single letter in that word one by one, from I equals to 1 to the end of the word, and the dictionary logic is lines from line 12 to 17 here. If is key to the this one here. If the letter B is already in our dictionary, we add, and to its the count. If the letter is brand new, we add it to the dictionary and set it to the count equals to 1. It means every time a letter appears in any word in the entire table, the dictionary records it. And for suppose a simple example, let me give you a simple example. Imagine our table only had 2 words, a cat and a car. The code picks up cat, it adds C is 1, A1 and T1. These are the non-repeated words to that, and they will add to the dictionary. Then it picks up the car. Here it adds another C and another A and then adds R1. So the final value of D will be C equals to 2 and A is 2, T is 1, R is 1. It's literally just a tally of every single alphabet using in the whole table. So it means the dictionary D represents the frequency count of each alphabet in the table. That's it. How many times the letter is coming. That's it. Now the final question. Here we have a data set. In this they are asking what shopping bills data set. What will D represent at the end of the execution? Okay. So in line 1 we have D equals to empty dictionary, and we start with a complete empty dictionary here. This will eventually hold all our items like shops and the prices, And from line 2 to 6, the main loop here, the code looks at every single bill, card bill, shopping bill, and in our pile, and for every bill it calls the update dictionary procedure to process the items on that bill. From the line 9, for each a in the y list, y item list, now we are inside a specific bill. This line starts a loop that looks at the every single item a listed on that one bill, and at line 10, c equals to a dot item name. For suppose we take the name of the item like milk or bread and store it in a variable c, and in line 11, if is key d comma c, which means we check is this item c already in our big dictionary d. If no, we can go into the else block. We'll go to the else block, which is in the line 21 to 23, and here if the item is not in the dictionary, it's the first time we have ever bought it. That's it. And at line 22, we create an entry for that specific item, and in line 23 we record the shop name, and then we record the shop name and the prices we just paid, and set the flag to the false. We start at false because we haven't seen a price change yet. If the price is changed, then we'll change. Next, again get back to the line 12. If is key dictionary c y dot shop name, if the item is already in the dictionary, we check have we bought this item at this specific shop before. It means at line 17 to 18. Else block, if yes or no. Here the else block. Here in this, if we bought the item before but never at this shop, it means not in the same shop. Okay, so in line 18 we will just create a new sub entry for the specific shop and record the price and the set flag to the false again. And again coming back to the line 13. Here the if d of c of y dot shop name and the price is not equals to a price. It means if we have bought the item at the shop before, we compare the old price in our dictionary to the current price on the bill. Here we are asking has the price changed, which means the not changes not equals to, means the prices changed. At line 14, d of c of y dot shop name, here the flag will be true. Flag is equals to true. This marks that this specific shop does not have a constant price for this item. So after putting all the bills through this logic, if the price of an item at a shop stayed the same every single time, the flag stayed false. It means if the price was different even just once, the flag was flipped to true. So by looking at the choices, the flag is set to true if and only if the item is sold for a variable price at that shop. If the price is never changed, the flag would have stayed false. So that's it for the quiz 2. I hope you understood all the topics that were covered in this lecture, and that's it. Thank you.